Okay, in this video we're going to go through the steps for implicit differentiation, and we use implicit differentiation to find dy dx when we can't get y on a side by itself. So for example, you'll see down here the example we're going to do, we have x squared y plus xy squared equals 6, and there'd be no way for us to get that in terms of y equals blah blah blah, just stuff in terms of x. So what we're actually going to do is use the chain rule here. We're going to think of y as a function of x, which means whenever we take a derivative of something like y squared, we have to think of that really being like f of x squared. Okay? And so if we were taking the derivative of that, we would have 2 f of x then times the derivative of f of x, f prime of x. Okay, because of the chain rule. So whenever we see something with a y that we're taking a derivative of, we'll take the derivative like we would, 2y, but then we multiply by dy dx, which is the derivative of y. Okay, so that's just kind of the idea behind it and how we're actually using the chain rule. But let's go ahead and write out the steps. So the first step is we're going to differentiate both sides of the equation with respect to x, and so we treat y as a function of x. So what this means is anytime you take a derivative of y, multiply by dy dx. Now in some books, if you look other places, they might just use a y prime instead of dy dx, and they mean the same thing. We've talked about all the different notations. I like dy dx just because y prime, you never quite know if like the prime was a smudge or if it's just a y, so dy dx, you know it's not just a smudge. Okay, and then the second step is solve for dy dx. So you're going to have, in this step, won't involve calculus, it'll just be all algebra. You're going to have kind of a big ugly equation that'll have dy dx's in it, and you'll get all the dy dx's to one side, and everything else on the other side. Then you'll factor out dy dx and divide by everything else to get it alone, the dy dx alone. Okay, so let's actually go through this process. Here we have x squared y plus xy squared equals 6. So we're going to differentiate both sides. So we'll start with the x squared y, and here we have to use the product rule, right? We have an x squared and a y. So for the product rule, we're going to leave the x squared alone, and we'll take the derivative of y, which for just y, the derivative is dy dx. Plus, now we'll take the derivative of the x squared, 2x, and leave the y alone. And when you're leaving it alone, not taking a derivative, you don't need to multiply dy dx. You only multiply by dy dx where you're actually taking a derivative. Okay, so plus, now we'll take the derivative of the second part, xy squared, and again, it's a product rule. We have the x and we have the y squared. So we'll leave x alone and take the derivative of y squared, which will be 2y, just like you would x squared, but then since it's a y, we multiply by dy dx. Plus, now we take the derivative of x, which is just 1, and we leave the y squared alone, equals, and then the derivative of 6 is a constant, so the derivative there is 0. So first, let's simplify this a little bit. So we have x squared dy dx plus 2xy plus, I'm going to rewrite this as 2xy dy dx plus y squared equals 0. Okay, now we want to get everything that doesn't have dy dx over to the other side. So we're going to subtract 2x to the other side, and we're going to subtract y squared to the other side. So on this side we'll still have x squared dy dx plus 2xy dy dx equals a negative 2xy and a negative y squared. Now that we have the dy dx's on one side and everything else on the other side, we can factor out these dy dx's. So we'll have dy dx times x squared plus 2xy equals negative 2xy minus y squared. And my last step is to divide by x squared plus 2xy. So our final answer here is dy dx equals negative 2xy minus y squared over x squared plus 2xy.